let's move on with the second session of presentations, and we'll start with Mengli Zhang and colleagues who are presenting a work on bridging the ambient environment and HRI using site-specific robots to create context-conscious interaction. So welcome, and please go ahead.
Okay. Thank you for the introduction, and here with the co-authors Jackson Harden and Janelle Brooks from Clemson University and Professor Keith Green from Cornell University. And just very quickly, I was formally trained as an architect, and hence the interest in trying to integrate the ambient environment and architecture with HRI, which we think could be beneficial to the field, because interaction cannot be studied or created out of context. So we would like to propose this idea of the context conscious interaction as a strong concept, where the core design agenda is to further the involvement of the ambient environment in the HRI design process, where now the architectural design and corresponding theories and practice can play a more active role to help robots and interactions be more site-specific. And we position this concept as an extension, especially in scale, to past theories such as context awareness in ubiquitous computing, and incorporating the ambient environment and architectural design theories into the HR design process, we argue can augment the impacts of HRI and expand the research field. And we explore this promise in this paper, particularly by proposing a design instance representing as a generative outcome of this strong concept of this we call self-organizing robot team, or SORT for short, created to provide assistance in independent living environment. And we will use SORT as an example to demonstrate how context-conscious interaction is a strong concept in the following ways. Number one, the concept represents a generative tool driven by the architectural environment. And number two, the SORT robot is a design element, but it's also a part of a larger swarm artifact. And number three, it carries a specific use over time by switching between a task mode and an ambient mode. So in this way, I guess we are trying to design for its idling behavior. Lastly, SORT is a particular instance, but the context conscious interaction concept resides above it. And so in this paper, we very briefly describes the design and fabrication of this SORT robots and present very early results as a validation for the system's capacity. And as the HRI research continues and is more frequently being examined in the context of the home, we believe it is imperative for the research community to understand the HRI design process as a function of its context instead of being independent from it. With that being said, there are some questions we would like to pose to the community. For example, is there so if there is a correlation between HRI and the immediate vicinity, is there a cutoff limit? Meaning, if we take the robot as the center of interaction, and then we may need to think about, okay, what's the surface, what's the table it's sitting on, and then what's the room it's in with the human. Maybe we consider is there a view outside? Is the user during user study looking at the robot, or is the user looking at what's behind it? But is there a boundary where we can confidently say that that's the cutoff limit, and that's the entire universe we have to consider, and that's the edge of this particular interaction scenario? Thank you. That's all I have to say.
Very interesting. Do we have questions? Hands raised. So if there are no questions yet, I think I would like to ask you something. I think it's very interesting, this concept of or this idea of repositioning the robot as center of interaction, while we, especially the people that are trained as designers, might usually think as the human, the person as the center of interaction. So this shifts a lot all the thinking while you design, and maybe we can use this shift in perspective also to rethink how we how we approaching interaction design more in an ecological perspective. So I think your is really in that direction, considering the context.
Yes, particularly if we consider if we're already trying to draw theories from architecture, we might as well draw theories from, for example, environmental psychology. And then there are, I think, valuable lessons that we could pull to the HRI field. For example, there's this theorist, Bronfenbrenner, who proposed the ecological model of studying the how the ambient environment impacts human behavior. And if there is a robot that's already initiating some commands or trying to invite users to interact within some kind of environment, then that model would be very relevant. But then it kind of goes to the question of how far do we consider the different layers of scales of environment having an impact or having an effect on how robot and human interacts. It may be positive, it might be negative effects, and we I found a lot of times the user studies are conducted in a controlled lab environment, but when we deploy the robots, the context change.
Yeah. Yeah, indeed. Transform the context itself. So we also have a couple of answers to your questions about the cutoff limits and boundaries. So both Jared and Elena challenge a bit. So answer maybe not. Maybe there is not such a thing. I think we are running out of time. So thank you very much again, and we'll move forward with the next speaker, who is Sara Falcone, who is going to present her work on design challenges to achieve the sense of embodiment while developing a teleoperation system. Welcome, Sara.
Hello, everybody. Hi, I am Sara Falcone from the University of Twente, and today I will shortly present my work. So my focus is
we can't hear you well. Sorry, can you check 1 second? Is it only my problem? Can you repeat? No?
It started very clear, but it then changed.
Now?
Yes.
Yeah, yes.
Okay, great. Yeah. Headphones, microphone from the computer. Okay, now it's fine. Okay, so I will start from the beginning. So I'm Sara Falcone, and I'm a PhD student from the University of Twente. And my research focuses on the application of the sense of embodiment in teleoperation, where teleoperation is the control of a device and machine remotely, while the sense of embodiment can be defined as the perception or the feeling that an external body or part of it is considered as our own. And this is mainly defined by three definitions, which are the sense of ownership, namely the sense of self-attribution of the external device. So if we think about, for example, a robotic hand, this is easier to obtain, but if we think about the drone, it becomes already harder. The sense of agency, which is the perception of being fully in control of the device, and that our actions are perfectly mirrored by the device itself. And finally, we have the sense of self-location, which is this perception and full immersion in the remote environment, and also the total awareness of it. So this dichotomy between the sense of embodiment and teleoperation was something that I raised in the last decade. It was started to be studied, and it was demonstrated that achieving high level of sense of embodiment can improve task performance. And this is easier to get if we think about, for example, prosthetics, but there are also other fields such as rescue scenarios, social robotics, or industrial robotics, microsurgery, for example. So lately I started to work on a literature review where I started to review like the more used measures to assess, test, or the tasks that are used to assess the sense of embodiment and teleoperation. And what I noticed is a real lack of generalization. Actually, the main problem is that all the measures are really related to the task, and the task to the scenarios, and so on. So it's really related to the application. And this, of course, makes different, for example, to be the model in which we can say, okay, if we design a teleoperation system in this way, we can achieve this maximum level, for example, sense of embodiment. What I would want to bring to the table today, actually my main question to you, is that if you think, considering actually the topic, which could be a good starting point to start to be a more general and methodological framework with respect to a really strictly application related framework as we have right now. And actually, if you think that it would be possible to get something really general as I described. Thank you for your attention.
Thank you very much. Very interesting. And I'm curious, what's your early thought about your questions? Can we have general?
Yeah, so until now, where I think like it would be a super long work starting from now. For what we have from the literature is really like every kind of author or every kind of study, they decide to use usually a combination of qualitative and quantitative measures. So for example, self-report and questionnaire plus some physiological measure, and they're not really comparable for other studies. So every time we have to do like a post-hoc test every time to test the sense of embodiment for a particular teleoperation system. And so for now, we are really far away from something which could be defined as general. And yeah, so my thought is that it would be possible, but we really have to start from scratch. Like, yeah.
Nice. So a lot of work to do for you.
Yeah, this is nice, right? At least.
Great. So other questions? You were very fast and to the point. No, this is a comment from Christina. But if there are no other questions, let's move on. I think there will be some other discussions later about these topics. Thank you again. So now we have Marianne Bossema, and who is presenting a work developed with colleagues on robot body movements and the intentional stance. So a bit related, but from a very different perspective, I would say. Welcome, Marianne. If you're here, I hope.
Can you hear me?
Yes, welcome.
Yeah, so this study was done in the context of the Master Media Technology in Leiden University. And yeah, we explored the effects of robot body movements on the adoption of the intentional stance. So whether people ascribed intentions to the robot's behavior and its movements. And it's based on the theory of Daniel Dennett, who says that people see others in their environment as physical, or yeah, using physical explanations, or based on its design, or they take the adoption of they adopt the intentional stance, which means that they ascribe intentions to it. And it is shown already that seeing a robot as intentional can help predict and understand its behavior. So we thought it would be interesting to see if you can design for that. And yeah, our results show that people sometimes adopted the intentional stance, and it was an abstract robotic object, so it was not a humanoid robot or so, but sometimes people adopted the intentional stance. Expressive movement increased that ascription, but only in cases of surprising behavior. And in contrast, it decreased in, ascription of intentionality with unsurprising behavior. So we found that the emotion design should be, it should be designed expertly to help to support ascription of intentions. We think that in the future, robots may become more autonomous and interaction with may become more complex. So it becomes more challenging and also more important for people to understand what robots do and think. And the adoption of the intentional stance can help to explain their behavior. And so we think in general that the design should also help that process, and motion design, but can also be other things, other kinds of design that should help that. And it is also, it can also support a positive feedback loop for learning. For example, you can raise attention and then support giving feedback to a robot's behavior. And then the robot can learn from that, and also the people can learn from that. So it's some kind of process of attunement. There was another project of researchers, or a group of researchers working on the adoption of the intentional stance toward robots, and they proposed a tool to investigate it, and we took that as a starting point. But they used image sequences that told a story of robot behavior, and we replaced that with videos because we wanted to look at the movements. And those video questions were added to a questionnaire and then distributed. So that was, we improved this tool, but we think that this tool could also be used more often to explore people's reactions on robot behavior. So we have two statements. The first is that the robot intentionality is a concept, or maybe a problem that should be addressed in human-robot interaction, and that we should look into guidelines on how you can support it. And the other statement is about the method, that we think that using video questions and questionnaires can be an effective method for probing first reactions on robot behavior, because you have some kind of control. You can record the videos and then reach a lot of people. So that could also be something that we could discuss. You don't have interaction, but
Great, thank you. Very interesting. Also very nice. I mean the pictures of the video, the screenshots of the video are very nice, clean and neat. I think also in terms of its aesthetic quality, they are very interesting. So have a look at them in the paper, people. I think the last things you were discussing, the use of videos as a very meaningful way of exploring these kind of qualities, like intentionality as a, I think it's very interesting also because we internally as organizers, we were discussing what might be HRI specific form of intermediate level knowledge. And if we think about all the videos, HRI videos, which are usually accompanied by like annotations, that is also in a way maybe a form of intermediate level knowledge. And do you also see that? Or
I was you mean in like a special kind of annotated portfolio, but then with videos?
Yes,
so you show all kind of behavior and try to find out the common denominator.
Yeah, indeed, there is a lot of potential, I think, for studying HRI through videos.
And Gerrit has a question. I think he raised hand.
There is a question?
Yes, I have one.
Oh yeah, great, sorry.
Because I think this is very interesting, but one thing that pops up to me immediately, I do some acting as a hobby, and motion is super important, but it's also very dependent on the context. So if I raise my hand in a classroom, it has a completely different meaning from when I do it on stage or when I do it here in this Zoom meeting. how do you see this relation between the motion and the context in which you present it, and how do you think as a designer you can well, play with that?
Yeah, in the video we had scenarios that were some kind of story. So the robot was doing something that could be surprising or not, and then we looked at how people reacted on that situation based on its the differences between the movement effects. So we had expressive and functional movement, and then the conditions in the same story, and then looked at how people explained it, the behavior. But I understand what you say. It is there's not so much context when you have a video, and it is there's no interaction, so there's no incremental process of that you can react on what how people react, all these kind of things. So it's really about first impressions. But I think you can use it maybe next to other things to research this kind of thing. So because I think the biggest limitation of the study was that there was no interaction. So then that should be further researched. But the video questions gave a good point at what was at a certain pattern. So we could further investigate that then.
Yeah. Great.
Yeah.
Thank you very much also for the question. So thank you very much again, Marianne. Let's move on with Swapna Joshi. Did I pronounce it correctly? Are you here with us?
Swapna's not here, but I'm
Okay.
here.
Yeah. Hi. Let me check your name. Sorry. Waki Camino. Okay. We also have been in touch. So you're going to present your work on designing for bodywork in HRI. Again, another work on the body embodiments. So I'm really curious to hear more. You can go ahead.
Hi. So at our lab, we do a lot of storytelling session in intergenerational and child-robot interaction setting. And we have used Beam, and also we've been using this robot named Haru from Honda Research Institute with like massive eyes and body. And we basically started from this simple question of how can we boost the expressive quality of storytelling. I feel like we felt like we are not making the most of the capability of robot as well as our expressive quality. So, and we do Wizard of Oz quite a lot of time, and then we just didn't know how to make the most of it. So we started this using this methodology of body storming. So two researchers from the lab, we're quite familiar with the taxonomy of the body anatomy of the Haru robot. So we started like, hey, why don't we just try to act like as if we have the body of Haru? How would you express the particular emotion, or how would you tell a story? Which turned into like a bizarre session of like trying out in front of camera. But yes, and yeah, actually we found quite interesting result is that like a lot of people in the lab actually assign their hands to the eyes. So even though emotional expression can be like personal or a different degree depending on the person, there's some commonality in terms of how they would assign their body. And then we're thinking about like a potential application using the motion capture technology. And our like ultimate goal is to input the feedback from our body storming into the actual design of robot, aiming for more expressive storytelling. That's it. Thank you.
Cool. Thank you very much. Do we have questions? I think it's very interesting. Oh, yes. Waki, right? Is a
Yeah.
No. Yeah. So, Christina has a question. Do you want to just ask?
Sure. That is something that actually has very much related with my research, so that's why maybe I'm bringing it in. It's very interesting to use body storming. I use it a lot with kids to generate behaviors. But what I learned is that sometimes the difference between functional behaviors and expressive behaviors is really thin. So I wonder if you think that there is a dichotomy between functional and expressive behaviors, or what is your stance about this topic?
I think it's a really relevant question we have to explore. But one thing when we the reason why we really focus on expressiveness is that we do that in the nursing home setting, and people with cognitive disorders, sometimes you have to really exaggerate. So the normal behaviors, we realize that they don't necessarily pay attention when the robot makes subtle movement, where normal people realize as a movement, but people when you make exaggerated big movement, we call it expressive or maybe functional as well. I'm not sure, but yeah, the reason we came from there. So I don't know if I answered your question, but.
No worries, I think it makes a lot of sense, but we should maybe discuss about it offline.
There is another question from Anastasia, very briefly. Have you translated this to other robots yet? Do you have plans for expanding it to other robots? I wonder how people will adapt the body storming for various embodiments. That's a very nice question.
Yeah, we're trying to do that with Beam. There's some motion capture kind of work done with Now, I think, but it hasn't been done in the storytelling session context. So we're trying to do that with Now and Beam. We find it really difficult to do it with Beam because you have to operate and also be expressive at the same time. But yeah, we're trying to do it with different kinds of robots and see what happens in the future.
Great. So thank you again. Let's move forward to Hannah Pelican, who is going to present her work on intermediate level knowledge and conversation analysis perspective.
Yes, can you hear me? All right. Yeah, so I'm a PhD student at Linköping University in Sweden. And with my position paper, I kind of want to encourage critical engagement with the designer's knowledge about interaction, sort of what we bring from our first person perspective, in a sense. What do we intuitively know about interaction? And we are all competent members of societies. So we interact with people every day. We have sort of a good understanding how to do things with people. If you're stuck on a road and you want to sort of signal to somebody that they can safely pass in front of your car, you kind of have an intuitive understanding how to do that. Or on Zoom, when you sort of need to leave for the next meeting, you probably also kind of immediately think of okay, how would I do that? So what I want to stress is that we all have this understanding how to do things with other people, that we could even kind of refer to that as tacit rules of interaction that we all somehow follow. And when we design robots, we kind of bring that knowledge with us. So I think we should embrace that sort of we have this knowledge, but also engage with it more critically. Does it actually apply to robots in the same way that it sort of applies in our human-human interaction? And also, do we always have the right metaphor in mind when we kind of translate from human-human to human-robot interaction? Maybe we're sort of thinking of something that works. For example, also in the body storming, maybe we're thinking of something that then actually in the specific setting that we're working with is maybe a little bit off. So in the really detailed action by action level, it might not sort of work completely. So with the position paper, I want to present conversation analysis as an approach to engage with this tacit knowledge. Just very quickly, kind of a brief introduction. Conversation analysis is sometimes called as a micro-sociological method. So it's really looking at the fine details of interaction, sort of the machinery of interaction. And kind of acknowledges that interaction is situated and dependent on the context, but it's not completely random, but there are patterns that we can find. They're not sort of 100% fixed, they're not static, and we can break them if we want to. I think Gerrit had also shown that we can sort of break things in the interaction. Also, we can make these sort of awkward silences, but that's not sort of the typical sort of most common way how things would go, or how we would probably sort of tell somebody else, how do you do this in a good way? So how can we use CA? There's first of all a lot of literature that we can draw on. sort of in between theory and specific examples, because the way CA works is sort of like really grounded in single instances where you can really actually look at interaction almost like a script. But what I think is more interesting is the methodology where you videotape and transcribe. And in the paper, I sort of demonstrate a little bit how this could be done, that you work with like single cases, that you look at how do we actually do this. And throughout the design process, you could start with human-human interaction, improvisation, or just sort of going out and videotaping yourself and your friends, but then gradually kind of take this up with like different prototype levels of the robot, and to just kind of explore and validate, is our intuitive understanding correct, and does it work that way? So I guess that's sort of my paper, how can CA stimulate a critical discussion of what often remains tacit knowledge in HRI so far.
Very interesting, thanks. Do we have questions? I have a question. So when I think about conversation analysis and trying to understand the tacit knowledge about human-human interaction and how this can inform the way we approach human-robot interaction, I think it's a very interesting point. At the same time, I think, isn't it like focusing on conversation already a choice towards like a specific way of looking at robot design and human-robot interaction, like a human-like type of interaction, because like conversation is an exclusively human-human form, or well, not really. We also have conversations. We can have humans conversing with animals, for instance, but it's not mutual. So do you see this also in that direction and open to these forms?
Yeah, I think that actually the term is maybe not good, and there's sort of like ways people calling it interaction analysis instead, but then it's kind of hard, like what is it actually, what does it denote? So I think it's more like a kind of coming from a certain tradition, but conversation I think is in a sense bad, because it suggests that we're all sort of constantly sort of talking to things, but actually a lot of it is nonverbal. And I also try to like write that in the position paper, that you can see how things are actually like it has an action focus, so kind of not so much kind of talk, but it can also be nonverbal. So it can help us to also see how, for example, a bleep can be understood as a greeting. So it's really more looking at what are you doing with a certain gesture or talk or like a certain action. So I think in that sense, it's very relevant even for non-humanoid robots as well. So I think that's important to stress.
We have another question. So Benedetta says, thank you, Anna. Very interesting. Do you think this is a way to sort of imagine the not imaginable, to think of other ways of bringing new rules to HRI conversation?
I hope I understand the question correctly. I think it's interesting because it sort of has this connection to rules in some way, or sort of like to bring in like knowledge about patterns. So I think it is, in that sense, it is sort of like a very, very hands-on way of working with things. So I think it could, yeah, bring new things, potentially kind of deviate from the methods that we have now, sort of like working more with an action-focused approach. I guess, of course, quite detailed, but I think it's one tool that we could use to come up with different things. Yeah.
We also have a final question from Christina. Christina, if you want to ask it.
Yeah, so I'm very fascinated by conversation analysis, because I think that it brings in some concepts that could be important also to generate robot behaviors. And one of them, I think, is grounding, that you can explain better than me. And I was just wondering if you think it could be a nice design principle for HRI designers.
I think actually that's a really nice idea, because yeah, so the concept of grounding is the idea that you're sort of always building mutual understanding, that you're not sending the information and the other kind of decodes it, but that you're really sort of like building understanding together, and it's like there and then that you get it. So I think that would be quite important to actually fight this idea of like, oh, the robot is sending a message that you decode and then you move on, but it kind of stresses a more collaborative character, which I think would be quite important actually. And I think that might work as a yeah, design principle to stress. Yeah.
Great. Thank you very much again, Hannah. Let's move on. I think we might have another missing group. I don't know if Eduardo or Dagoberto or Jesus are here, but I think we might have had some time zone issues here. because Eduardo, the first author, is based in Australia, and we know it's a bit challenging time. So no one is replying. So I would say let's move on with Iskander Smith, who is going to present his work on predictive relations as part of Designerly HRI.
Thank you, Mayuliche. Thanks for inviting and being here. Can you hear me well? I hope, yes. So yeah, I work in Delft part of my time in the City of Things lab, design lab, which is a beautiful image of Mayuliche that she made for this paper that she wrote in the beginning of the research. But my research will be looking into the relation we have with intelligent things there. My specific topic and research is about how predictive knowledge is influencing the relations we have with intelligent things, but also in this case, I was really interested to also related to the relation we have with urban robots. And the idea or the thinking was we are really discussing. We have a lot of these discussion, thinking is about the interactions we have and the embodiment and all the interactions with the robots at the moment. But what if we have also these robots become connected to all these networks and get more information from situations that are happening on other places in same contexts on other spaces, but can be kind of predicting the way we will have an interaction with these robots, and how will this influence the way we will interact with these robots. And I think this predictive knowledge could be kind of a defining component of this interplay we have with robots. And so the perception of how we also have this interaction could be really influenced by this kind of new predictive information, predictive knowledge. Could be alienating, could be all kind of trigger all kind of new concepts. I heard already some interesting things that are kind of related. So my questions that I had before this workshop is mainly to think about, to have this, to see how this fits other discussions on HRI and Designerly HRI. So how will predictive knowledge be part of this maybe? And I'm looking at how I formulated the questions and how does this real-time interplay, how does this relate to stored and already generated knowledge in the interplay, and the predictive versus the existing. And that's I think how are we designing humans always? Are we always designing for humans, or are we also designing for the precision of these robots in this interaction? I think that's also one of the things that was mentioned. Someone I think that's a really interesting aspect. And I'm also still developing on a way to what kind of design methods there are. I have some ideas how to deconstruct the intelligence and translate it into a kind of adding this knowledge and learn from this process of doing this. I have some groups of students working on this kind of way to try to hack existing intelligent products into predictive things. And so I think that could be an interesting discussion, how to put this kind of design methods here. So that was my introduction. Oh, yeah.
Thanks. We have a question from Arkady. Quick question for Iskander. Is the predictive knowledge you're talking about the knowledge robots have of humans, or the other way around, humans' knowledge of robots? That was also my question. Or really?
It's about, I think first, so what is the knowledge that the robots or the system behind the robots have of the humans, or more precisely on the comparable interactions that have been taking place maybe in a different context or in the same context in a different space in a different time a moment in time. So really, so the question was, is the knowledge about human from the human or from the computer? So that was I don't know where we kicked out, but mainly in short, it is knowledge of the human. Yeah, just the knowledge that the robot has about the human, and that's using it in the interaction that the human and the robot has. That was my...
Great. Let's move on to the last speaker of this session. And thank you very much, Iskander. Next speaker is Marius Hogenmuller, who is presenting his work with some colleagues, and is going to present a paper with the title Beyond the Robotic Artifact, Capturing Designer LHRI Knowledge Through Annotated Portfolio. So welcome, Marius. I hope you're here.
Yes, I'm back. Yeah.
Great.
I also got dropped out, but now I'm back. Thanks for the introduction, Maria. I'm a PhD student at University of Sydney, and I'm doing research on media architecture. And like the last year, I was in particular interested on robots in public space, so working on urban robots. And I present this paper on behalf of Ray and Luke, who are also attending here, and Martin Tomic and Malte Jung. And in our work, in our paper, we present two of our research to design projects on urban robots through the lens of annotated portfolios. And these are two projects, Bubblebot, a mobile robot carrying the function of bubble blowing, which Ray designed, and Woody, a slow-moving robot which draws on the ground with conventional chalk sticks, which you can also see here in my background. So two urban robot projects. And there are quite a lot of similarities between this project, but the interesting thing was also for us that we were not aware of each other's project. So Ray did not know anything about Woody, and I was not aware of Bubblebot. And then at some stage, like 4 or 5 months ago, we exchanged our ideas about our projects, and then for this workshop we thought about analyzing our cases again through an annotated portfolio, which you mentioned before. It was initially introduced by Bill Gaver, and in our annotation process, we used existing strategies, for example, annotations concerning the interaction qualities and the design domains, and this helped us to articulate some of the resemblances across our designs, but also to shed like a light on the broader design context of ludic and playful urban robots. And further, we also adapted annotation strategies. For example, we looked into specific aspects of our robots' designs, for example, on the output that the robots are producing. And we also looked into captures of earlier stages in our design process. And we, for example, regarding the generated output, we found that both of us kind of tested and experimented with the robots on various grounds, and which also highlights the interplay between the robots and the immediate surroundings, that this is an important aspect as well, what we heard earlier already in talks. Another annotation strategy that we followed, we called contrasting ideals and reality. And here we looked into the early visions that we had for our robots, and we looked into the early renderings, and we realized that we both had this vision that we will create a fully autonomous urban robot, and that will have this like its own base station where it will autonomously move back for charging and like recharging the battery and charging the chalk and things. But then when we looked into the actual into the actual deployments of our robots, we realized we both were not capable to implement this fully autonomous robots, and instead we were every night we were carrying the robots back to a safe place, and we had to exchange batteries manually. And through this strategy, we also kind of wanted to showcase it's important, to look into early visions and to have a better understanding how we as a designer also approach or what is our understanding of what a robot is capable of doing. And on the other hand, also looking into alternative human-robot relations, where basically in the final deployment we acted as the caretaker of the robot. And so we found this annotation strategy really interesting to consider for HRI. And in our paper you can find more details about the different strategies. And our takeaway message is also to use annotated portfolios beyond the the finished design artifact, but also look into all the captures during the design process. And this can be really interesting to also kind of highlight the broader concerns of the field. And yeah, we would also like to discuss maybe further for which type of projects annotated portfolios can be useful, and maybe also in which cases annotated portfolios have limitations, like we talked about movement. What about conversational agents, which is also an important aspect, and where's also design research in HRI.
Thank you very much. Very, very interesting work. And I think it's really, this work shows how a bit what we have been discussing in the introduction. So how powerful can be annotated portfolio to bring out something like the figure of the caretaker in terms of relationship between the robots and the human. And I think it's really nice. And I have a question for you, since you have been engaged with this process. Do you think annotated portfolio are meaningful and valuable only when are done by like me as a HRI designer on my own work, or can be done with an external point of view on someone else's work, in your opinion? And then we have a question.
What Geeke asked now in the chat, yeah.
Oh yeah, maybe we can give more space to that.
I think that's also something that Bill Gaver is talking about. I think in his original paper, and that this can be also done by not the designer, but he's also talking about like that. You have different insights, and you also have a different lens then obviously if you analyze someone else's work. And I think in the way we use annotated portfolios now, really being the designer was crucial for the way that we annotated our work, because we looked into this different stages of the design process. But I think it could be applied also to work from different people. And I think what could be also interesting to further develop is maybe also to compare if you technology in public space. Augmentation of public spaces, to also look into like previous technologies which engage people in playful interactions, and also contrast that to these works, and what are similarities and differences between using a robot for this augmentation of public space compared to, for example, public displays or media facades as an example.
And there is a question from Geeke Ludden, I think, who says, nice work. I wonder who should annotate the portfolios, just the designers or other people as well? And I think this is related to the previous one, but with also a slightly different topic. Oh, okay, it was exactly the same, but I was wondering, because I was inspired by this question, do you see also like the non-expert view as a potential interesting source of meaningful annotation, or no?
I guess it's a good question. I guess it could be really interesting, and could probably also bring a different lens on the projects again, like how do people interpret it. So probably could be something really interesting to further explore, but we haven't thought about this aspect at this stage. But I mean, maybe it would be also, yeah, I think what the point that you made in terms of you know, that a non-expert is doing annotations on this project. I mean, related to HRI, but also like in terms of annotated portfolios beyond HRI in HCI. And I'm not aware if someone was doing research in this regard. Yeah.